learners, in this video, we will discuss the reciprocal lattice vector of a BCC lattice, which we call body-centered cubic lattice. As you know, the BCC unit cell has the lattice points at all 8 corners and one additional lattice point at the center of the body. In total, this makes 2 atoms per conventional unit cell, one contributed by the corners and one by the body centered. So because of this, this is not a conventional, this is not a primitive unit cell, since we know that a primitive unit cell contains only one lattice point per cell. For example, in the case of simple cubic lattice, the unit itself is primitive. So our first task is to construct a primitive unit cell from the conventional BCC unit cell. In this figure, I have already shown the X, Y and Z axis for the references. Unlike the FCC case that we discussed in our previous video, where we chose a corner point as the origin, here we will take the body centered point as the origin, and from this point we will draw the vectors connecting the 3 nearest corners like this. Let's denote this as vector A, vector B and vector C. These vectors form 3 faces of the required primitive unit cell. Now to complete the remaining 3 faces, we need to construct additional unit cells. So I extend the construction by drawing 3 more unit cells, one along the x-axis, second along the y-axis and one along the z-axis like this. So please note that I'm not going to use the corner lattice points. Instead, the only thing that I'm going to use is the body-centered lattice point. So in the next slide, you can see that I have drawn only the body-centered lattice points because those are the ones which we require. So from the body-centered lattice point of the cell along x-axis, I connect it to the 3 corner lattice points of the adjacent shared face of our chosen unit cell like this. And similarly, I repeat the same process for the X, Y and Z axis. And by joining these points, we can now see that the figure forms a primitive unit cell. Here, the lattice points are only at the corners, which confirms that it contains just one lattice point per unit cell. Our next step will be to calculate and write the mathematical expression for vector A, B and C. Just like we did in the BCC, this is my origin point. If we take the lattice constant to be A, so I'm sure you can easily find that this distance is A and this distance is A. So for the A vector, we have to move halfway round along y-axis, halfway along z-axis and halfway along the negative x-axis. So the expression for A vector will come out to be like this. And if you remember, this is the same expression that we got for the A star, that is the reciprocal lattice vector for the FCC lattice. Similarly for B vector and C vector. Now we will be constructing the reciprocal lattice vectors from these A vector, B vector and C vector. So the expression that we have got for A vector, B vector and C vector are A by 2 minus I cap plus j cap plus k cap. B vector is A by 2 I cap minus j cap plus k cap, and C vector is A by 2 I cap plus j cap minus k cap. Calculating for A star equals to 2 pi by V B cross C, where V is A dot B cross C. So our first task is to calculate V, and for that we have to calculate B cross C, that is the vector multiplication of vector B with C, and we'll do it by determinant method. Our vector B is having, so I'm writing A square by 4 outside so that it will be simplified. 1 minus 1 1, and C is 1 1 and minus 1. So when we'll calculate this, it will give me I cap will be having 0 component, j cap will be having 2 minus 2 and k cap will be having 2. So B cross C will come out to be A square by 2 j cap plus k cap, and then I'll multiply it with A dot to get V, and in A cap we are having minus I cap, j cap and k cap, so our result will be A cube by 4, 1 plus 1, then again A cube by 2. So the expression of V is this. So writing the expression of A star, which is 2 pi by V, that we have calculated to be A cube by 2, and B cross C we have calculated to be A square by 2 j cap plus k cap So A star will come out to be 2 pi by A j cap plus k cap. Similarly, we can calculate for our vector B star, and that will be 2 pi by A k cap plus I cap, and vector C star will be 2 pi by A I cap plus j cap. So as I've already told you that the reciprocal lattice vector of BCC are the direct lattice vector of FCC. So this is a very beautiful relationship between BCC and FCC lattice. FCC and BCC, the direct lattice vector of FCC are the reciprocal lattice vector of the direct lattice vector of FCC are the reciprocal lattice vector of the BCC.